Section 6.2, Systems of Linear Equations and Applications. Part 1, Solving Systems of Equations in 3 Variables. Solve the system of equations by using elimination. Here we can choose to eliminate x, y, or z first by pairing these equations into 2 different pairs. I'm going to choose to eliminate x. I'm going to pair these 2 equations and then these 2. So for the first 2 equations, I'm going to multiply the top one by -2. That way I'll have a -2x and a 2x, and when I add them together, the x will be eliminated. So I multiply the top equation by -2, and I get -2x minus 2y minus 2z equals -10. The second equation, I'm going to write it as it is right underneath, and then add the 2 equations together. Then I get 0x, 1y minus 3z equals -8. Then I'll take the second 2 equations. So for the second 2 equations, I'm going to take this middle equation and multiply it by -1. So I'd have -2x minus 3y plus z equals -2. And then I can add these 2 equations together, and I get 2x minus 2x is 0, 3y minus 3y is 0, -2z plus z is -z, and 4 plus -2 is 2. Divide both sides by -1, and I get z equals -2. Now once I've eliminated x in 2 different pairs of equations, now I have this system of equations. Z equals -2, and y minus 3z equals -8. And then I can solve that system of equations, whatever it takes to solve it. In this case, I'm going to use substitution by plugging -2 into this z. So I have y minus 3 times -2 equals -8, or y plus 6 equals -8, y equals -14. So far I know z and I know y. Then I'm going to take both of those and plug them into one of my original equations. I'm going to use the top equation. So I have x plus -14 plus -2 equals 5, or x minus 16 equals 5. Add 16 to both sides, and I get x equals 21. So my solution would be the point 21, -14, -2. To check your answer, you would plug in this point into all 3 equations, make sure it works on all 3, and if it does, then you have a correct solution. Let's classify the system of equations as consistent independent, consistent dependent, or inconsistent. So a system is inconsistent if it has no solutions. So we know it's not inconsistent because there was a solution. A system with at least one solution is consistent. So this one is consistent. A system with a unique solution is independent. So this one is consistent independent because we got one unique solution. If the system had infinitely many solutions, it would be consistent but dependent. So this particular system of equations, the 3 planes intersect at exactly one point. In this case, it's that point right there.